Good afternoon or good day to you. So today we're going to review once again how to solve problems involving forces. So today we're going to have a more complex problem which involves two variables being searched for. So how does it go? So let's read first the problem. You wish to push a cart across a frictionless surface. So you apply a 20 Newton force for a period of 3 seconds. As a result, the cart goes from rest to a velocity of 2.3 meters per second. What is the mass of the cart? Hmm. So let's follow Gressa in order for us to solve this one. So what is the given in this problem? So first, we have the force, and the unit for force is Newton. And then we have 3 seconds. 3 seconds is a unit for time. According to this problem, the cart goes from rest to a velocity. So there is no acceleration but a velocity. So let us remember that in order for us to solve problems involving Newton's law, we need to either have the force, the mass, and or the acceleration. But in this problem, there's no acceleration, but just the velocity. But it's telling us that the cart goes from rest, so meaning since the object is at rest, there is no velocity. So we could say the velocity or the initial velocity of the object is 0 meters per second. Next, it goes to a velocity of 2.3 meters per second. So that would be the final velocity of the object when it already moved. And lastly, it is asking us for the mass of the cart. The problem is, how am I going to solve this? So there's a problem within the problem. I don't have the acceleration. I only have the force, the net force. So how am I going to solve this problem? Well, that is how, this is how we are going to solve this. We have to find first the acceleration. And if you remember from your grade 7 science, you have learned that the definition of acceleration, it is the rate of change in velocity over a period of time. So that would be velocity over time. Since we have two velocities here, we have to take into consideration the final and the initial velocity. So we are going to use this kinematic equation that the acceleration of an object is based on the difference of the final and initial velocity divided by the time it took for the change in velocity. So the change in velocity divided by the time or the period of time. So if I have the velocities and the time, I would be able to solve for the acceleration as I've seen. Yeah. Just look at our example here. In the given, we have the velocities and we have the time. So most likely we will be able to solve for the acceleration. So we are going to use this equation. So we just need to punch in the different variables in our solution. So the final velocity is 2.3 meters per second. So please take into consideration the final velocity and initial velocity. Sir, okay lang ba na magkabaliktad yan? No, it is not. It will not be correct if you change the initial and the final velocity. If you switch them, most likely the answer would also be changed in terms of the sign. So you have to be very careful in punching in the variables, the values for each variable. So for the final velocity, it should be 2.3 meters per second minus the initial velocity, which is 0 meters per second, divided by the time, and that is 3 seconds. Moving forward, am I going to be able to solve this? Yes, napakadali na lang yan. 2.3 minus 0 would still be 2.3 divided by 3. That would be 0.76666. So it will be a continuous 6 So we round it off to the nearest hundredths. And eventually, rounding it off, we will be able to get the value 0.77. Try it in your calculators for yourself so that you could see it for yourself. So we will have the acceleration of 0.77 meters per second squared. Sir, am I going to stop solving the problem now? Not really, because you are looking for the mass of the part. So we are just going to use the acceleration that we have found for us to be able to solve this problem. So now we have these. So we are going to focus on these two given now. So we have the acceleration, which is equivalent to 0.77 meters per second squared. Let us remember that velocity and acceleration are different in terms of the unit of measurement. So if it is meters per second squared, that is acceleration. So we are looking for the mass. And let us remember that the mass, and if you're looking for the mass, since the net force is equivalent to the product of the mass and the acceleration, so the opposite operation of that would be division. So since most likely the force would be the bigger number, we divide it with the smaller ones. So net force divided by the acceleration this time. So moving forward, we just need to substitute the net force, which is 20 newtons, and the acceleration, which is 0.77 meters per second squared in our solution. So the net force is 20.0 newtons I got from the given, and the acceleration is the one that we have solved earlier, 0.77 meters per second squared. Sir, will I be able to find the mass now? Yes, most likely you'll be able to. So let us remember that Newton is equal to kilogram meters per second squared. So to eliminate, since we're looking for the mass, we want to show where we got the kilograms. So let us remember that Newton, again, is kilogram meters per second squared. Since the denominator is meters per second squared, we can then cancel the meters per second squared from kilogram meters per second squared, and we will be left with the unit kilogram. So our answer is 25.97 kilograms. So this problem requires a 2-unit significant figure as its accuracy. So we are going to round off this answer to the nearest 2 significant units. So since we have 4 significant units, we are going to reduce it and round it off to the nearest nearest whole number for us to be able to get 2 significant units or figures. So 25.97 will be rounded off to 26. So the mass of the cart is 26 kilograms. Do you have questions? PM me in Messenger or in class. See you. I hope you have learned something. All right.